have the test scores coming in?
Hopefully by the end of the week. I'm still waiting on Miss Cross before I publish.
Were the test scores bad?
I don't think so, but I mean they're lower than normal, but I told y'all that when we started this section.
Can you tell us what the average was?
I can't. Jonathan, Christian. Alright, you guys picked up the notes last time, so you need to find those in your binder. Jonathan, alright, today we're going to start off with our U substitution process, which I've mentioned once or twice at this point, but this is going to be probably the single most important skill that we have this semester, so we'll practice it today and again next class. It's not one that you need to see a million practice questions to get it, but it takes quite a bit of practice before you feel comfortable doing it. So today we're going to do the notes together real quick so I can introduce you to it. We've got a 8-question book assignment that we will do together.
Mr. Johnson.
What?
Could I get to the restroom real quick? I wasn't able to go before class.
I mean, you're already tardy, so I don't know why it matters now. And then I've got 3 Khan Academies for you guys to do over the same thing, and so that'll be the end of class and maybe a little bit of that for homework. Okay, so if you guys remember last semester with derivatives. Okay, girls, can y'all please stop? Last semester with derivatives, we had to learn a bunch of different derivative techniques, and one of those was the chain rule. And trying to undo the chain rule is often too much to do in our head, which is where U substitution comes into play. So we learned this process, we practice doing it, and this process will take care of the undoing the chain rule for us so that we're not having to do some mental gymnastics to try to figure out what's going on. So I guess my question would be, you don't have to write this down, but before I tell you what the U substitution process is, how would you guys go about integrating this? Okay, so like that, and then of course plus C. You guys are racking up the tardies today. Okay, so everybody's okay with that? Yes? No? Okay. This is what we are going to do on question 1 after I show you how to make the question look different. So if you can do this at the end of the question, then you can do U substitution with a little bit of practice. So in U substitution, we have to pick out part of the integrand to be U. This part takes some practice. So in fact, one of your 3 Khan Academies is on just trying to pick out the U, and I'm going to suggest you do that one first when we get to that point. You'll feel more comfortable about picking that out the more of these questions that you do. But just a good rule of thumb here is that U is usually the thing trapped under something. So in this case, I see that we've got some stuff cubed. So a good guess for U would be the stuff under that, something like x squared plus 1. Now at this step, you don't usually know if that's a good guess or not, but you have to put something down to get started. The next thing that we do is we're going to take the derivative of both these sides with respect to U. Or, I'm sorry, with respect to x. So the derivative of U with respect to x, write it that way instead of just U prime. It'll help you in a second. And then the derivative of this side with respect to x would be 2x. And then finally we multiply the dx over. So I'm guessing what U should be. It's usually the thing trapped under something. I'm taking the derivative of both sides with respect to x, which creates a du over dx on the left, and for this question, a 2x on the right. And then I'm multiplying this dx over. So you can almost think of this as not really a fraction, but you can think of it like a fraction where you can multiply this over. We are going to try to take this statement and this statement to make this look different. Instead of a bunch of x's, we're going to rewrite it to where we end up with a bunch of u's. So since I have defined x squared plus 1 to be u, this is like u cubed and 2x dy, this is why I need this as well, 2x dy is the same thing as du. So I'm making substitutions. I guessed the u, I plugged it in. I solved for du, I see that that gets plugged in, and everything has to have a place. Everything has to be accounted for. I've got this as u cubed, and all of this was equivalent to du. Well, this is what I asked you at the start of class. Can you solve this one? Of course, because you can raise the power by 1, divide by the new power, and put plus c. The only other thing you need to do is this particular question didn't ask you to do, it doesn't say anything about u. So we need to plug u back into the problem. So instead of putting u in my answer, I will put what u is equal to. So what that just did, again, this is a process that you have to practice a bunch before you feel real comfortable. But I just did the antiderivative without having to do the chain rule in my head. If I was to take the derivative of this, I would bring the power down. That would make this a 1. I would lower the power by 1, giving me an x squared plus 1 cubed. And then because of chain rule, I would need to multiply by the derivative of the inside, which is 2x. So it just naturally created the chain rule process for me, or undid the chain rule process for me. So that is what we're doing. So once again, we're trying to guess a u, solve for du, and then we're trying to substitute that in to make the question easier to do, easier where we could do it in our head. Okay, question 2. So integrate 5 cosine of 5x. Now honestly, this is really just one step of chain rule, so it might be easier to just try to undo one step of chain rule in your head, but u substitution can do that for you. So I look at this, and to me, the thing that's trapped inside of something is 5x. It's trapped inside the cosine. So that's what I would guess u to be. Take the derivative of both sides with respect to x, and multiply both sides by dx, so that you solve for du. We need this, what u is equal to, and we need this, what du is equal to. We're going to try to use these two to rewrite this question where it doesn't just have x stuff in it, but it has u stuff instead. That's why it's called u substitution. So, in place of cosine 5x, bless you, I could say cosine u, because I have defined u as 5x. And what is 5 dx equal to?
D.
Right here. 5 dx is exactly equal to du. We need these variables to match. If I want my variable to be u here, it doesn't make sense that this would be a dx. That says that we're trying to anti-derive with a different variable. We want these variables to match. We want it to all just be u stuff. Okay, well now it's phrased in a way that I can do this much simpler in my head. What can I take the derivative of to get cosine?
Sine.
Okay, sine. And because this doesn't have bounds, we need to put plus c. And you should not circle this as your final answer because the original question has nothing to do with u's, but just simply plug this back in for u, and there's your antiderivative. Notice if I took the derivative of that answer, I would get a cosine 5x times 5 because of chain rule, and that's what we were trying to do the antiderivative of. Again, this whole process is in place of us trying to undo chain rule in our head. Again, that's just a one-step chain rule, so honestly you might prefer to try to do that in your head instead of this process. But okay, so now I've got to start asking you guys questions so I can see where you're hesitating and what parts I need to try to emphasize more. So at this point you should know that you need to solve for u and du and plug those in and rewrite the question. What do you, and there's no wrong answers here, it's fine if you're not guessing the correct u, but what do you think u should be in this question?
X squared minus 3.
That's a good guess. X squared minus 3 is trapped under something, in this case to the 4th power, so that's probably what u is going to be. Okay, take the derivative of both sides with respect to x, and then multiply the dx over. Now, using these two, well, maybe not the bottom one just yet, but using these, we rewrite the question. Instead of having x's, it's going to have u's. So, instead of saying x squared minus 3 to the 4th, what could I say in place of that now?
U to the 4th.
Good, that is just u to the 4th. And what is equal to x dy? Good, I'm glad you're hesitating because that's almost a trick question. Do we know what x dy is equal to? Right, so we need to do one more step here. I need to know what dx is. So on this side, if I need to divide by 2, this side I need to divide by 2. So instead of saying x dx, I can put 1/2 du. Again, this process allows us to kind of just take out the mental work out of it. We can just do the process instead. Now, this is where you should feel good because this is what you've been practicing. Raise the power by 1, divide by the new power, put a plus c, But instead of leaving u in your answer, you need to plug in u back into that. And of course, it's never a bad idea to check with derivatives. If you bring that 5 down, lower the power by 1, and then multiply by the chain rule, you will go back to this original thing. You can check that with derivative. Okay, do y'all have a question on that? Okay. Number 4 is a little bit harder of a guess, but does anyone have an idea of what you think you might need to be in number 4? Okay, make a guess.
Sin x?
Okay, so let's say you pick sin x. Sin x is not going to be correct, but this is why it's okay. If you pick sin x, then a step later, the derivative of sine is cosine. Multiply the dx over. So I guess I could call this u, but do I have the other pieces? Again, everything has to fit. Do I have a cosine squared dx? No. So maybe that's not a good u pick. So instead, why don't you try cosine x? I know cosine x is probably the u because it's trapped under the square. Remember with trig functions, we write squared a little bit differently. We put it next to the trig function, not next to the x, so that we can tell we're squaring cosine and not squaring the angle. Now when I take the derivative, I get negative sine x, multiply the dx over, and then I'm going to try to use this and this to rewrite the question. So instead of saying cosine squared, I could say u squared. And do I know what sine x dx is equal to?
Negative du.
Okay, good. So kind of, but not exactly. If you have, I really think you need to physically go one more step. If the other pieces are sine x dx, write that below it. Think about what you had to do to the right side to know what you need to do with the left side. Instead of saying sine x dx, we can put negative du. Again, I know the process is kind of a hassle, but the alternative of trying to do it in our head is just unrealistic. Now we can do the things we've been practicing. Raise the power by 1, divide by the new power, and make sure you don't leave u in your answer. U substitution is a tool to help you do that in your head, but this question has nothing to do with u, so our answer shouldn't have a u. And of course you can check by taking the derivative. Bring the power down, lower the power by 1, multiply by the derivative of the inside because of chain rule, and you'll see that you go back to the original. Okay, so those are indefinite integrals where we can just slap a plus c at the end. The other one that you will need to feel comfortable with after a couple classes of practice is definite integrals, and they have one extra step to them. So we will need to be careful about these bounds in just a second, but let's not worry about that just yet. We'll worry about that when we get there. You need to think about what u is. Take the derivative of both sides with respect to x, and then solve for du. You're going to have to do that on every u substitution question. If you pick the wrong u, like I worked out last question, it's usually fine. You figure it out in just a second. Everything has to be accounted for. Everything has to have its place and fit in perfect before we try to do that. All right, so what would you guess u to be?
X squared plus 2.
Okay, that's what my guess would be because it's trapped under the cubed. If I took the derivative of both sides with respect to x, this becomes du dx, this becomes 2x. So du is equal to what? Good, because you're really just like multiplying the dx over. Not really, but that's how it works. Okay, now we're going to try to use this information to make this look different. So instead of saying over x squared plus u cubed, I'm going to say over u cubed, because I defined the u to simplify the x squared plus 2. And the rest of the question is x dx. Everything else has to fit perfectly, not close, perfectly. I can't just slap du there. Du is not equal to x dx. Du is equal to 2x dx. So if you have x dx, write that, make one extra step. You don't have to do this every time, but make one extra step. Realize you're dividing this side by 2, so you would have to divide that side by 2. 1x dx is the same thing as 1/2 du. Now, the way I would hope that you would do the antiderivative of this is to rewrite this, raise the power by 1, divide by the new power, and we don't need to slap a plus c on there because we have bounds. But this is the part you need to be careful with on this type of integration. In fact, you really should probably write this down the first time. 1 and 2 are x bounds. They make sense if you're talking in terms of x, but we changed it to u, so our bounds should match up with u bounds. So it's not 1 to 2 anymore, unless it's a coincidence. We need to think about when x is 1, what is u, and when x is 2, what is u? Well, we've got this nice little statement here that'll do that for us. When x is 1, u is 3, and when x is 2, u is 6. Do you guys see how I'm plugging in 1 and 2 for x and solving for u? Again, we're having to do that because 1 and 2 were the bounds for x. I rewrote it in terms of u, so I need my bounds to be in terms of u. But otherwise, it will finish the same way. You can plug in 6 the first time, which would be like that. Plug in 3 the next time, which would be like that. Subtract those, and then you've got the -1/4. You can finish the arithmetic. You don't need to finish the arithmetic for your notes, but I'm not worried about the arithmetic. So same u substitution, but if it's a definite integral where you know the upper and lower limits of integration, you need to change them from the x numbers to their corresponding u numbers. 1, 2 in terms of x is the same thing as 3, 6 in terms of u. Okay, let's do that again. Okay, what do you guys think u is? Okay, that's a good guess. Du dx would be the derivative of that. It should be cosine x. And then solve that for du by multiplying the dx over. Sometimes that's enough, sometimes you need to do one extra step. But we're going to plug this in here. So instead of calling it the square root of that mess, we can just call it the square root of u. And if this is a perfect fit, then go ahead and just plug it in. If it's not a perfect fit, you need to do one extra step like we did on the last couple. Cosine x dx is exactly equal to du. Now, if you leave it pi and 3 pi over 2, your answer is going to be wrong. Again, that's in terms of x. We need them in terms of u. But if I plug this in over here, when x is pi, u is the sine of pi plus 1. when x is 3 pi over 2, u is the sine of 3 pi over 2 plus 1, which is 0. Sine of 3 pi over 2 is negative 1. Okay, and then from there, now it's not anything different unless you just dislike the use. But raise the power by 1, divide by the new power. And plug in our numbers and finish like we've been doing. Again, it's only the first couple steps that should feel new to you. So this is like u to 1/2. Raise the power by 1, divide by the new power, and we want to evaluate from 1 to 0. That's not the same thing as evaluating from 0 to 1. So plug in 0 the first time, plug in 1 the next time, subtract those, and multiply by the 2/3 that was there. So not only is this taking care of chain rule for us, but it's also indirectly taking care of product rule and quotient rule. There's a lot less processes with the integration because U substitution does so many of them. Okay, we've got one more for the notes, and I'm going to just keep on going here because in a minute we've got like 7 or 8 book questions, so there'll be more time for you guys to do some misguided practice. Okay, U should probably be what? Okay, so du over dx is equal to 2x, just taking the derivative of both sides, and solve that for du by multiplying the dx over. Start to rewrite your question. Instead of saying cosine of this stuff, we could say the cosine of u, where this u substitution is trying to simplify the problem to where we can do it in our head. But the rest of this is not just du. You need to be careful. I wish that it always worked out that way, but it doesn't. This is where the chain rule is being taken account of. The leftover pieces is x dx. Du is not equal to x dx. It's equal to 2 times that. So divide this side by 2 to know exactly what 1x dx is equal to, and keep your equation balanced by dividing that side by 2. Instead of saying x dx, you can say 1/2 du. Okay, the bounds were 0 to 2, but when x is 0, what would u be? 1. And when x is 2, somebody else, what would u be? 5. You have to use this statement. If you're going to rewrite it in terms of u, your bounds need to be in terms of u. Okay, integrate the way we've been doing. This would be an unmemorization thing. The thing I can take the derivative of to get cosine would be sine. But now it is 1 to 5. And since I've changed these bounds, I don't have to plug this back in, by the way. On the other questions, I didn't want my final answer to have a u in it, so I would have plugged this back in. But since I've changed these bounds, leave it as u right here. You would plug in 5 the first time, 1 the next time, and then subtract them like you've been doing. Sine of 5 doesn't simplify, and sine of 1 doesn't simplify, so you'd have to leave it like that. Okay, so as I said, now you got an idea of what we're doing, but this takes a handful of practice before you feel comfortable with it. So we need to quickly move along to blank piece of paper. You want to copy those 8 questions down. We're going to do these together. Next class, I'll have you do some where you can work a little bit more at your own pace. But at this point, I need to do lots of hand holding with you. Also, good news is that we don't have many more book assignments left for us the rest of the year. Got this one. I've kind of split up in two parts. We're going to do part of it today and part of it another time next class. Okay, 30 seconds and I need to switch the screen. So if you don't have it copied down now, you'll have to finish copying it down later. Okay, so I'm still going to help you with all of these, but I will be asking you to practice parts of them, bless you, before I just tell you, because you need to start to see what parts are, after just a couple of examples, what parts are intuitive to you and what parts are not intuitive to you. Okay. So here's question number 1. What I would like you to do in this question is make a guess about u. Tell me what you think du over dx would be equal to and what du would be equal to. Just try those parts. And then I will finish it with you, or for you. You just need to follow along. Now, once you have those 3 things written down and you start looking at the original question, you probably have an idea if you picked out the correct u, because all of that stuff in red to the right that I'm asking you to do is supposed to be a replacement to the original question. So I would have picked 225 minus x squared to be my u. Why do you think I picked this as u? Right, it's trapped under something. That tends to be the u value. Not 100% of the time, but 95% of the time. To go from here to here just means derivative. So derivative with respect to x, derivative with respect to x. And then the last part, you just need to multiply the dx over. So we are certainly going to use this, and hopefully we're going to use this. Sometimes we need to tweak it one more step. Sometimes it's enough. But now think about the substitutions we need to make. Instead of calling this the square root of 25 minus x squared, I can just call it the square root of u, because that's what u is. And instead of saying negative 2x dx, I could say what? du. That's what this is. Perfect fit. Now everything's in terms of u. I want to integrate something in terms of u, and there's a du here. These variables have to match to make sense. So we can finish it the same way we've been finishing them since we came back in January. Think of this as u to the 1/2, raise the power by 1, divide by the new power, and put a plus c because we don't have limits of integration. Okay, what should I do before I circle this as my answer though?
Plug in the u.
Right, if you take the derivative of this, your answer has u's in it. This has nothing to do with u's. You need to replace u back with whatever you said u was. You don't need to do that for definite integrals, but for indefinite you do. Yes?
In between, how come the du goes away? Like, where does it go if it's negative 2x dx?
Negative 2x dx, negative 2x dx is the same thing as du. So I just changed all of this to du.
Right, but like, in between, like, the second and third step,
Uh-huh.
when it, yeah.
This is just defining the variable. So like if this had x's and y's, we would need to know which one we were trying to do the antiderivative of.
Okay.
But you can't leave this x and then have this in terms of u. You need it to all be used for what we're doing.
So it just kind of goes away.
Yes. It goes away when you do the antiderivative. Okay. Again, this is a process. If you don't try to learn from each question, then it's never going to get easier. Take a second to reflect on what you think you might not have done if I'd asked you to do the whole thing by yourself. And then in question 10, I want you to do the same things. Guess a u, solve du dx, and solve du. And see if everything fits or if there's any adjustments we need to make. Okay, I didn't finish all the way, but I'm thinking there's probably going to be one extra step on the right this time. All right, somebody I've not heard from, what did you pick out to be your u?
6 minus x.
Okay, 6 minus x cubed is a good guess. The derivative of both sides with respect to x would give you that, which means du is what? Guys, I'm trying to go quickly here because this is, the sooner you get on to the Khan Academy, the less homework you have. So we can drag feet if you want to, but
Negative 3x squared times dx.
thank you. So you're just multiplying the dx over. You should start to think about making replacements here. Instead of this stuff, you could say u to the 5th. But everything has to be accounted for. Do I know what x squared dx is equal to? Not exactly. I'm close, but I don't know exactly. This time you need to go one more step. Write down what you want it to be. I have an x squared dx. Think about what you have to do to this side, and you've got to do the same thing to keep your equation balanced. Divide by -3, divide by negative 3. X squared dx is the same thing as negative 1/3 du. Are you guys okay with where the negative 1/3 is coming from? I promise you, if you take my advice and you are systematic about writing this out each time, if you make yourself write this last step, it's really easy to see where the negative 1/3 is coming from. If you do not make a habit out of that, I can promise you there's going to be times you miss stuff and you're going to be confused on where things came from. But the rest should be easy because we just raise the power by 1, divide by the new power, slap on a plus c. I guess we could multiply these two, but don't leave u in your answer. Put u what u is equal to. Of course, in a high stakes question, like a quiz or a test, if you had a moment or two, you could quickly check that by taking in its derivative. Power rule, chain rule, should give you exactly what we started with. Not only is that checking a good idea, but the more often you guys check those, the more familiar you're going to be with derivative rules. You don't want to have to start over on those when we get to the AP review. Okay, so any questions, any specific questions about 10 before we jump on to the next one? Okay, I'm going to start to ask a little bit more out of you. So the next question wants us to solve the differential equation, and all that really means is try to figure out what the original function was. That's what it means to solve a differential equation. So integrating this side gives me y, so we need to integrate this side. Well, to integrate this, I'm just going to stop you before you get going on here. You should be able to integrate this no problem. There's no u substitution needed. The thing that I could take the derivative of to get 4x would be 2x squared. Raise the power by 1, divide by the new power. But for this part of the question, I couldn't tell you what I have to take the derivative of to get that mess. This really needs the u substitution process. We really need to rewrite this in terms of u. So out to the side, do what we've been doing, try to pick out a u, solve for du dx, solve that for du, maybe do one more step, but try to write this in terms of u. Try to write all of this out. Get everything to fit the best that you can. I guess I should add, when we integrate this, we do have to define that this is dx. So there is a dx here when we integrate. So. You don't have to finish the question, but try to rewrite it all in terms of u. Remember, we already did the 4x. You don't need to worry about the 4x, just this part. Question? assume you're either finished or stuck somewhere. So, what could you possibly be? Again, I'm really just focused on this part right here.
-16 x squared.
Okay, and if you pick 16 minus x squared, then du dx would be negative 2x, which means du, multiply this over, would be negative 2x dx. And then you should start to see if this and this are able to make substitutions for all of that. Instead of having over the square root of this stuff, I could say over the square root of u. And do I know how much 4x dx is equal to? I don't know if you guys are okay or if you're stuck.
du.
It's yes or no. Do we know what 4x dx is equal to?
We need to figure it out.
Not yet. We're going to have to figure it out. That's right. That's why over here sometimes you want to do one more step. Make yourself write what you want it to be, the last substitution piece we need. Then you can think about, what do I have to do to this side to get to this? I need to multiply it by -2, which means I need to multiply this by -2. Keep your equation balanced. Now, instead of saying 4x dx, I know that's the same thing as -2 du. Now that we have one variable u, and it has been greatly simplified, and the du has already undone the chain rule for us, we can finish integrating this how we have been doing. Maybe rewrite this with exponent rules. Raise the power by 1, divide by the new power. And don't leave u in there, put what u is equal to. I guess I also need a plus c. There could be a constant that we can't see. We always need that when we integrate. Now again, I know it's a hassle, and I'm not asking you to do this every question, but in the back of your mind, remember you can always check by taking the derivative. Derivative of this gives me 4x. If I did the derivative of this by bringing the power down, lowering the power by 1, puts it in the denominator, multiply by chain rule, that stuff should balance out then. Okay, I would like you to try question 33 from beginning to end. Guess a u. Again, there's nothing wrong with guessing a wrong u. I'm going to guess wrong u sometimes as well. But once you know what u is and what du is, you have a pretty good idea if it's a close substitution. If it's close, or if it's perfect, substitute and integrate. If it's close, you might need to do one more step there to the right. And if it's not close, you maybe have picked a bad guess for you. All of that becomes more comfortable the more practice we squeeze in. If you finish faster than everybody else, check your answer by taking the derivative. That one should not be too terrible. To check your answer to. And if it looks good, I squeezed in the next question at the bottom. So you're welcome to get a head start on it when you're done with 33. So we've got just 5 more out of the book we're going to look at today, including these 2. Grace, I need you to put your phone up and join us. Are you done with both these already? 34 also? Does anybody need more time for 33? Okay. So again, if you checked your answer by taking the derivative and it's correct, you can tune me out and move on to 34. You know it's right, it's fine. But the process should have been, I would have guessed u to be pi x because it's inside of sine. Du dx would just be pi, the derivative of both sides with respect to x. Multiply the dx over, and then I'm definitely going to use this, and I might use this, but I have to use these to make this look different. Instead of saying the sine of pi x, I could say the sine of u, and instead of saying pi dx is exactly equal to du. Now, again, that's the only part that's new. The setup is the only thing that's new. From here, you guys should feel very comfortable. The thing that you can take the derivative of to get well, I guess that does have one step of chain rule. What can we take the derivative of to get sine? The derivative of cosine is negative sine. So you need this to be negative as well. Negative cosine would give you sine. That's a little bit trickier, but plus c, because we don't have the bounds. Plug in u before you finish. Take the derivative of that to check. Now again, if you're still struggling with undoing power rule and undoing the memorization ones, hopefully that'll get better with some practice, but you're definitely on the hook for that. That's going to be at the end of each question. Yeah.
Derivative of sine isn't just cosine?
I'm not asking for derivative. We're going this way. I'm asking for antiderivative. You need to think the derivative of negative cosine would give you positive sine, because the derivative of cosine is negative sine. If you're not solid on those rules, it's real easy to mix up when you're supposed to add a negative and when you're not supposed to. Okay, does anybody have other questions about 33? Okay, then 34 should be along the same lines. Once again, I'd like you to try to see how it goes. So there's 34. If you're feeling good about it, check your answer by taking the derivative and move on to 55. And if not, I will go over it in a minute.
Oh, it's over 2. Oh, you're right, okay. Oh, yeah, that's weird. I didn't think about that cursor.
Christian, you want to tell me how you started this one?
I put u as 4x.
Okay, good guess. Which means this is,
4.
which means this is
4 dx.
x.
And then,
Okay, you start to rewrite this. Did you call this sine of u? And then did you put du?
Yeah.
That's
I
it?
put 1/4 of that, so.
Very good. So the only thing you had left to replace was dx. I don't know what dx is equal to until I go one more step. Divide by 4, so divide by 4. I promise, please make that part of your thought process every single question so that it's just out of habit. Okay, what can I take the derivative of to get sine?
Negative cosine. No.
Positive cosine.
Positive cosine.
Oh no, I'm sorry, you're right. Cosine would give us negative sine as a derivative. So negative cosine would give us positive sine as a derivative. Plus c, and plug u back in before you circle your answer. The derivative of that gives you sine 4x. Derivative of cosine something is sine something. Negative sine something times by 4 for chain rule. Timesing by 4 cancels this out and puts it back to be a 1. Everybody okay with that? Diego, you got that? Okay. All right, 55 wants you to take the derivative. If you integrate the derivative, you get the function. So they want you to integrate this, and instead of having plus c in your answer, they're giving us information that we can use to solve for c. So you should have an actual number in your answer for number 55. But to do this, if you can't see how to undo that chain rule in your head, which is always risky anyway, you really need to rewrite it with using u substitution. So,
I have a question.
yeah.
Does there need to be dx?
Yeah, there should be a dx. Thank you. Integration doesn't really make sense without a du, a dx, a dt. You have to define the variables. So. Okay, so try that one. And then the next to last one we'll look at on the board today is 72. So 55 is an odd question. I don't know if that's an easy one to check with derivatives, but you could check in the back of the book. If you're getting it right, you can move on to 72 and leave this behind. Okay, somebody want to volunteer what you did for 55 and I'll do the writing?
So u I got 1/2 x.
Okay, sounds good.
So then u over dx would be 1/2.
Sounds good.
And then du alone is 1/2 dx.
Sounds good.
And then I did du du equals dx.
Okay, so I don't know, hold on one sec. I don't know that I need that yet. But when I start looking at this, I've got sine of u. I need to replace a negative dx, and I don't know what negative dx is equal to. But if I know I need a negative dx, you don't have to do that mental gymnastics in your head. Write what you need below it, and then whatever you're doing to this side, do to this side. So, what was the last part? Good. Multiply both sides by -2. So instead of saying negative dx, you should have done -2 du. That's the step that's undoing some of the chain rule for you. Take what you have, write what you want, think about what you did to this side, that's what you have to do to that side. Yes?
Could you have left it as negative sign, and then when you integrated it, have just cosine for negative cosine?
Yeah, you could do that. You could do that. Personally, though, any constant, just like derivatives, I usually pull them out and just worry about them later. Just simplifies the question more times than not. So the thing that we can take the derivative of to get sine would be negative cosine. We don't need to say u. We can actually plug in what u is equal to. And now we can use this. This is what we call a general solution plus c. Particular solution, we should be able to solve for c. If I plug in 0 for x, plug in 6 for y, I can solve for c and get the real answer here. If I plug in 0 for x, this goes to 1, which is 2. Subtract that over. This was 6. Subtract 2 would be 4. So c is 4. The final answer should be this plus 4. C is 4. Now I'm not writing that down. Are you guys okay with how I'm using 0, 6 to solve for c and change c to 4? Again, you've been doing that, so I have to kind of assume that we don't need to touch on it too long. Okay, sounds like it's getting a little bit better. I think we got 2 more, but 72 is the first one in the book that is a definite integral. You need to be hyper aware of these intervals. When you integrate, it's not going to be 0 to 1 unless it's just a coincidence. Okay, try that if you haven't yet. Now, this is not an easy one to just do the derivative of to check your answer, because you should have a number answer with those bounds. Also, this is an even question, so you can't check in the back of the book. But if you finish before us, I'm going to give everybody about 2 more minutes. This is one you could check in your calculator. Remember, your calculator can do definite intervals. So, one person at your table might throw it in the calculator to see if it's what y'all are getting. Okay, if you did not finish or you did not have time to check your answer, make sure you're looking at what I'm doing to make sure we're on the same page here. I would guess this to be u. Again, I don't know for sure, but that would make this negative 2x, and du would be negative 2x dx. Just multiply the dx over. You start to make replacements. This could be the square root of u, but the other replacements I need is x dx, not negative 2x dx. So this side needs to be multiplied by negative 1/2, so this side has to be multiplied by negative 1/2. Negative 1/2 du is the substitution you can make for x dx. Again, write down what you need, think about what you have to do to this side, and then do the same thing to the other side. Then it's no harder than an Algebra 1 question. But the part I'm concerned about is the bounds. Remember, 0 to 1 are the bounds for x. I'm rewriting it in terms of u, so my bounds need to change. When x is 0, u would be 1. And when x is 1, u would be 0. The rest of the question we've been practicing for a while. Raise the power by 1, divide by the new power. Guess we could multiply these two together. Plug in the top bound first, plug in the lower bound second, subtract those, and 1/3 should be your answer. If you don't change the bounds, your answer is going to look wildly different. 0 to 1 is in terms of x. You've got to plug that in and change them to u. For this question, that would be 1 to 0. Not the same thing as 0 to 1. Okay, specifics about that one. That was the next to last one we're looking at on the board. Okay, then last one for the first part of this assignment. Is 74. So at this point, I should be feeling more comfortable. Maybe not 100% comfortable, but more comfortable in the first couple. So go ahead and try it. This is an even question, so really the only way for you to check your answer reasonably is going to be plugging it in your calculator and see what your calculator says. If you've got that, you can move over to the Khan Academies. Addison, you done with this? Okay, I'm assuming somebody needs more time with this. Everybody's finished with this one already? You got it wrong. Okay. All right. You picked out u to be 1 plus 2x squared. So du dx you should have said was 4x. So du is 4x dx. Okay, you start to do this. This is 1 over the square root of u. And then the other parts is x dx. X dx is 1/4 du. Did you do that? Okay. Did you leave the bound 0 to 2?
Yes.
Okay. 0 to 2 is when you're in terms of x. When x is 0, u is 1. And when x is 2, u is that 9? Is that right? So our answer comes from 1/4. Integrate this guy. Raise the power by 1, divide by the new power, and we're going to evaluate him from 1 to 9, not 0 to 2. 0 to 2 is x, 1 to 9 is u, the equivalent u. So your answer should have come from 1/4 times, actually I'll just multiply the 2, 1/2 times plugging in 9, then plugging in 1, subtracting those, 1/2 times 2 should be 1. That's okay? This is typically one of the harder things this semester for students. So it's fine for you guys to be struggling. It's fine for you need to ask a lot of questions, but I can only go off of what you guys are giving me. Do you understand the general idea of how we're trying to rewrite the question to make it easier to do in our head? Okay, the practice I need you to get in, and you guys have just under 20 minutes because we got a little bit of a slow start, but I have 3 Khan Academies that I'd like you to get 100 on. I really think you should pick out the one that is about trying to pick out what u is. That one should be pretty quick. I just want you to guess what u should be. That one should take less work. So do that one first. And then there's one with indefinite integrals where the answers are all going to have a plus c. And then there's one where they're definite integrals where you need to change the bounds and you should have a numeric answer. I need you to have 100% on those 3 by Friday. So I will come around and help, but of course on the Khan Academies, if you do miss one, click the Get Help button, see where you went different than what they said, and try to learn from your mistake. If you don't learn from your mistake, it's going to take you more practice questions. Making mistakes is fine, but try to improve on those so that they occur less often the more questions you do. And I will ask for that book assignment at some point, so make sure that you store that away in your binder for Of course, on the indefinite integrals, you might want to check your answers by taking the derivative before you submit your answer in Khan Academy. That might keep you from having to restart sometimes. And on the definite integrals, you could check your answers by putting it in the calculator. And you might correct some of your mistakes before you submit them and have to restart on that as well. So my preference would be that you go slow and careful and knock all 3 out in one try. But if there's 1 or 2 of these that you just have to practice a lot, then you need to practice a lot, because that's what this is about. Wi-Fi's not been great in here. Been okay?
I almost did one entirely in my head, but I forgot just like one of the exponents. So disappointing, so.
It ends up being more work if you don't do it carefully and not in your head.
Well, one that was careful. I was writing it down in my brain. Today,
That didn't work out.
only because of a missed that. Like,
Probably the exponent, probably exponent 4. Usually if you think about, if that's gonna be u, then d is gonna be like 4x cubed, and that's pretty close to that, so that's how I know that that's a pretty big yes or no. That's all.
What's your time?
Didn't know that they had that one in there. For that one, you would just need to use the calculator only. It's like a form, I'd have to think about it in a second. I think it's a form of arctangent, which I haven't made you memorize yet, so. So feel free to just throw that one in the calculator.
I was gonna ask if I could do it on my phone, but I was like,
Yeah, you can do it on your phone, it's fine. I don't mind if you're using your phone for class stuff, it's when you're on your phone and not paying attention. That I have to say something.
Yeah, my computer isn't working either, so I'll be doing this something.
For this, would u be 3 plus cosine x or
Well, what would the derivative of that be?
negative sine?
Which is pretty close to that,
Yeah.
so that's probably your.
Probably.
Yeah.
Just wondering, I have to go here,
Mhm.
and from here, u just becomes 0.
Why would u become 0?
Because when I take x, u to the negative 1, or u becomes 1, u to the negative 1, and then I raise that to 1.
You can't do that.
Times.
That's not undoing power rule, that's one that we memorize.
Oh.
And that's why we need to memorize that one, because you can't do the power rule there, because
Okay.
you need natural law.
Natural law.
There you go, yep.
Okay.
And that's why that property is needed.
I see.
I guess I should also warn you that your AP exam usually asks you to do U substitution several times, 3, 4, 5 times usually for AP exam. So that's good if you prepare well. Yeah, I didn't know they had those mixed in. If you remember on the top of one of our circuits that we did, I had told you the derivatives of inverse sine and inverse tangent. Do you remember that?
Yeah.
Well, I mean, see if you can find them, but I'm not gonna make that.
It's not this one, it's the one we did before. Yeah, it's the ones I didn't know how to do.
I would have asked you to put it. I think, just glancing at it, so.
Oh, it's tangent.
Yeah, inverse tangent, the derivative of inverse tangent is the one that looks like this.
is there a change of one there?
Well, we're looking at X, it's gonna be 1, right? What is it? Well, don't worry about that, if you get it. Not everybody has the same question.
Yeah, but they're all cycled through, so if I fail enough, it's gonna show me that's real bad.
Alright. What did you guess is you? Well, if you take x to be u, then du is gonna be one dx. And one dx is gonna help you make any input. I would probably call u secant.
That's kind of weird.
No, I'm just
E to the x.
because what is the
E to the
derivative?
2x.
Here's the right, on this one.
What's the derivative of
Finding
secant?
u equal to the bottom part plus x plus e to the 2x. And I ended up with du equals 2e to the 2x.
This is one we memorized last semester. The derivative of secant is going to be secant tangent, and that's where the rest of that stuff comes from.
Like you take the 2 down, like you
Yeah, that's, I think
So that
that's
would be my
chain
guess.
rule, isn't it? Technically?
On how to rewrite
E to
it.
the 2x. wouldn't that
But
be
again,
chain
I don't ever know for sure until I actually try to make
So if I
it.
take because no, it's e to the, and we'll do the same thing, and then 2x times 2.
Derivative of tangent is.
Yeah, so it'd be 2 e to the x.
Okay, so maybe
Because it would be
so maybe
chain rule, right?
tangent is
Yeah,
u,
but it would be 2e to the 2x. Start over again.
right?
I thought
And du would be secant squared, but that might sound like
Oh wow. So then I point where du is equal to. So then maybe u, then maybe it's just
because the derivative of tangent is.
That's technically what I'm inside the thing.
So du is secant squared dx. So based on that u, you rewrite that as u squared.
I'm not sure about this.
And that's really gonna be easier.
It's probably just not e to the power. I got it. It's just one.
Yeah, so I'm taking this one, I didn't have it. This is one that, so, I use our natural law test, right? Because I had it in memorized. So I can find the derivative of the outer tangent.
So if it's e to the natural, it would 2. That's like e to the e of the 2.
I think so, yeah.
So that would just be 2.
But once you memorize that.
I think that's how that works, yeah.
You can just kind of see how it's.
That sounds
similar
right.
to format, but they're plugging something.
So then that would just be.
Well, yeah, that's-
So how do you remove the x will just be a So, okay. For this one, when I plug in, use natural times e to the natural of 2. Would that simplify it just 2?
The natural log of 2, all of that would just be 2.
Okay. And then 2 plus 1. Just the okay. Wait, thank you.
Bro, I finished it.
Okay, see, I don't know about that.
So as with that
I'm not gonna do the whole thing, but I need to see where it was in the
Are you gonna do like, you just read the book?
I read it.
So this is also a custom version of that too.
You seek it or just on yeah, but so that's what I'm thinking.
How'd you even do both?
But no, not like separately.
Yeah.
Seek it as a because you know when you have cosine, like cosine square law. It was cosine. Everything on the inside was cosine because cosine was being squared. So cosine x. This is secant x because its tangent is what's on the inside. That's square.
So 1 over integrating 1 over.
Yes.
To the L.
I hate that. I can't think right now, I'm too tired.
That's why we knew that property.
To the power of L.
So rewrite your question.
I don't really.
My guess is that you probably going to go down there if you don't remember. Derivative is secant tangent.
Let me tell you.
Now you just want secant squared.
Oh. Yeah.
Okay, so that's. So you already gave an derivative.
Oh wait, that's it? It's just secant? Oh, I understand now.
The derivatives of secant.
I understand. I understand. I was having a hard time.
Any of those that you don't remember, you're gonna get real
Yeah.
creative on how to solve them.
Exactly the correct this is
What can you take the derivative of to get you to use?
so when I have 1 plus c.
Not say you, but what you would be called is so if we take the derivative of this check, the derivative into something is going to be into something. So that's there. Times the chain rule, that would be times the derivative of x to the
It was
fourth,
just Ellen for me.
which would be 4x cubed. So 4 times the fourth goes to 1. And 7 times the next goes to 1. Okay, you guys are down to about 2 minutes here. So finished or not, you need to find a stopping place.
See, I didn't want to have that situation, so you have
It should just fall into place. It's lined up. It's like sword in the stone, but the opposite.
Okay.
You know what sword in the stone is?
Yes, where it's like hard to like pull it out.
Yeah.
It's hard to put it in.
And I guess that works out. You're just like